All right, so what we've done is we've drawn out the sampling distribution, assuming that the null hypothesis is true, and then we've plotted our sample proportion to see how unlikely it would be if the null is true. What we're going to do now is actually go back and calculate the p-value that we defined a couple of videos ago. So what this p-value represents, and I think I'm going to do the shading on this graph first, is if you go back to the definition, it says that it's the probability of obtaining data more in favor of the alternative than the data that we actually observed, if the null is true. So the if the null is true part, that's how we drew this distribution in the first place. Data that would be more in favor of the alternative hypothesis would be any proportions larger than 0.32. So anything over here is going to be more in favor of the alternative hypothesis that the true proportion is different than 0.25. It's also, though, going to be anything on this other side is also going to be more consistent with the alternative hypothesis than what we actually observed. So both of these shaded areas are what the p-value actually is. So it's the probability of obtaining data more in favor of the alternative hypothesis than what we actually observed here if the null hypothesis is true. So what we could do to figure out what that shaded value is, you should be able to provide a rough estimate, like maybe that looks like it's about 30% or 0.3 of the entire area of this graph is shaded. But we want to be able to calculate it exactly. And so what we're going to do is calculate a z-score that we could then use with stat113. And so our z-score is going to be our observed sample proportion minus the mean of that sampling distribution, which was p naught, so it was centered at 0.25, divided by the standard error that we calculated earlier, which is the standard deviation of that sampling distribution. So in this case, our z-score, if you plug in those numbers and calculate that out, is 1.1475. Then we could draw the z distribution, which it's been a few weeks, but you might remember that the z distribution always has a center of 0 because you're subtracting off the mean, and always has a standard deviation of 1. Put our observed z value that we just calculated on here, and then shade the area of the two tails. And so this shaded area matches the area of the graph that's shaded on page 5. So on the previous page, that area we just shaded matches with what we've done here. And so then finally, it's not easy for me to switch between this dot cam and my laptop, but we'll talk more about this in class. You should be able to go to stat113 and find the shaded area exactly. And so if you do that, you wind up with the shaded area of 0.251, which looks plausible based on our graph, considering that the area under the entire curve is 1. It seems reasonable that that shaded area would be about 25% of the entire area, or 0.251. Okay, so we have this p-value now. which represents the probability of obtaining data that's more in favor of the alternative hypothesis than the data we actually observed if the null is true. And what we're going to do on the next page is finally use this p-value to write a conclusion in context of the problem. So I think I'll pause this video here, and then we will have one more video concluding this problem.